Kamilah Taylor, and I'm an engineer at Gusto, the people platform that provides payroll and benefits for small businesses. Today, I'm going to talk about some lessons I've learned while going from 0 to 1 with Mobile and GraphQL. But first, a little bit about me. I was born on the tiny island of Jamaica, which usually leaves people thinking this. Ironic, since I'm the world's slowest runner. My reality is that I grew up as a shy kid with a love of Legos, books, and robots. My love of robots got me into computer science, followed me into grad school, and was my entry point into software engineering before I moved to Silicon Valley and got into the world of mobile. Fast forward in time, and I found myself last fall in the situation that many watching this may have found themselves in. Sometimes you want to build an app. You may be also lucky enough to need GraphQL. You haven't used GraphQL before? That's fine, we'll learn that too. Your understanding of what the schema should be is changing and we're adding new features? No problem. If you found yourself in such a situation, you probably identify with this. This is fine. Everyone has to start somewhere. For us, when we started working on this app, there were 3 main questions that we and our wider team had, and that we have continuously asked ourselves. The first of these questions, so I'm using Apollo iOS in my app, in addition to my networking stack. What goes where? The schema is evolving. How do we keep up in a not painful way? So you're telling me that the engineering team now has to think about multiple clients? What does that look like? Over time, we worked out some answers for these, and to be honest, there's a lot we're still working on. But today, I'd like to talk about some of the solutions we've already found. We were in a world of trying to figure out what goes where, because we already knew that we wanted a modular app architecture and that we also wanted to use Apollo iOS. For a little context here, the problem with a monolith iOS app is generally well known. Swift codebases get large and unmanageable. Compile times increase. Libraries get tightly coupled to the code. And the team starts to experience a lot of merge conflicts. So we started with these guiding architecture principles. We'll have a modular app. We'll try and enforce boundaries between modules where appropriate. We'll practice encapsulation, especially for external dependencies. And we'll use the coordinator pattern for navigation, something that we won't go into too much in this talk, but is still helpful context. We started with our main framework, called home in this diagram, and started adding frameworks for our main features. At first, this was just one feature framework, but we knew where we were heading. Our main home framework has to handle setting up the network stack. At first, it was the only framework interacting with the networking layer, since it initiated the authentication flow. But as we started looking towards our first feature framework, we started wondering how we were going to honor our architecture principles and also pull in the Apollo client. The problem we were facing is that we were looking at a future where we'd have multiple feature frameworks, and we needed all of them to access the data layer without creating a dependency on Apollo for every feature framework. Our solution was something that we call the data service layer. Here, you can see that our main framework is still doing the work of sewing everything together. So it talks to authentication, Gusto Network Manager, and App Data Service. The great thing is that all of our feature frameworks simply talk to the App Data Service when they want to request data from the network or from the cache. The App Data Service and Gusto Network Manager have the explicit dependencies on Apollo, but our feature frameworks do not. This was a huge win for us. We were able to break up our code base into modules. We separated our infrastructure layer from our feature layer. And we set ourselves up to be able to pull some of our infrastructure layer modules out completely as shareable libraries. Let's take a closer look at what's going on with the App Data Service. App Data Service is doing most of the heavy lifting with Apollo. It not only contains the Apollo client, but also the GraphQL files and the generated GraphQL models. Because it still needs to run on the networking stack that we'd initialized, it does have a connection to Gusto Network Manager through the network transport delegate. We've also added wrappers around methods like fetch, perform, and watch that the rest of our app will need. On the right, our feature frameworks are able to interact with the GraphQL models, make requests and mutations, all without having an explicit dependency on Apollo, knowledge of the Apollo client, or knowledge of how any of it was set up. Encapsulation was a really important guiding principle, and this definitely wins this for us. Our feature frameworks never need to know that Apollo is even running under the hood. We also centralize how everyone interfaces with the data layer. And we hide some of the details of what the network manager is doing from the feature frameworks completely. We were able to use our modular app architecture to encapsulate and create those boundaries we seeked around Apollo and around our data layer in general. Our next hurdle was something we really only experienced once we were some months into development. And that was what it meant to have active app development with an evolving schema. Our life became build the app, define the schema, build the app, repeat, etc. Add in some early experiments with mock data while we were waiting on standing up the schema and some realizations of how the schema should have been defined, and then throw in some new use cases and business requirements just for fun. Then you get this. The problem we started facing is that over time, our understanding of what we wanted the schema structure to be changed. And with active feature development, sometimes the schema had to be updated. We knew that we wanted to use MVVM and the coordinator pattern. And once we started using these patterns, we realized that we could further localize knowledge and access to the data layer. Let's look at what this looks like in practice. Over in data service land, we define our queries such as employee query, have our generated models such as employee.graphql.swift, and our fetch method that obfuscates the Apollo client and also handles things like the cache policy. Over in feature framework land, our profile view controller wants to load data that would be returned from the employee query. We have our view model make the request to the data service for data. In this case, we'd like to get employee details. Get employee details then goes to app data service, calls fetch, and gets that raw value back. At this point, our view model parses the data and pulls it out into fields the view controller will actually care about, like full name, which becomes a string. It then passes these parsed values back to the view controller. This leaves our view controller ignorant of GraphQL and what the shape of the queries are. This was another big win for encapsulation and boundaries and decoupling. Within our feature frameworks, usually only our view models interact with our data layer and have knowledge of the GraphQL models. Our coordinators also occasionally interact with the data service, usually when they're handling a flow that's spread across multiple views. This brings us part of the way, but there was still more we had to learn. Our next approach, adding extensions to our GraphQL models, grew from the following situation. GraphQL generated models end up with deeply nested types that reveal the exact shape of the query each time we need to interact with the model. This means that when the schema evolves, perhaps moving the fields around, we end up with having to change that in every view model or coordinator that interacts with that model data. We had some really tedious refactors that happened when that started to happen. And this is how we started working on using extensions. Here in our sample query, called feature query, you can see a typical nesting of fields. To get to current enrollment, you have to go through employee, then feature, then current enrollment. Over in the view model, you can see what it looks like when your app needs to access current enrollment. It has to go feature data.employee .feature.current enrollment. You can imagine that if we moved current enrollment one level down or moved it out from being nested under feature, we'd have to change the call site, not just in feature view model, but everywhere that interacted with that model. Enter the magic of Swift extensions. When we add an extension to that GraphQL generated model, featureQuery.data, we can encapsulate the logic around where in the tree this value lives, and the rest of your app never needs to know. Here, we've defined a current enrollment variable that returns employee.feature.current-enrollment. And now the view model can just call featuredata.current-enrollment. This means that when the schema changes, we can make the change just at the extension layer and hopefully nowhere else has to change. And if it does, because an underlying type has changed, the fallout is reduced. We've handled schema evolution by limiting access to the data layer using patterns like MVVM, and we've decoupled the code from the shape of the schema by using Swift extensions where appropriate. Oh no, I think this is wrong. Okay. And finally, software engineering is a team sport. Moving to a world of multiple clients can be different. Okay. The team was used to designing APIs for a web client that lived at the back end, but now we had to figure out how to design not just for multiple clients, but for a mobile app that has its own release cycle. We've come up with a couple of solutions that have worked for us so far. The biggest lesson was that we started to design the schemas to encapsulate business logic. This example is similar to something that jumped out at us as incorrect. Imagine we're only allowing an employee to add 5 bank accounts. Of course, we don't want to hard code the max number of accounts on each client, which we've done here by having this type of logic check. Because the schema can be so flexible, you may be tempted to then just add all the fields that you may need. So then you add an extra field for that maximum number of bank accounts. But if the client still needs to combine multiple fields to know if they need to show a screen or disable a button, then we've again left business logic being implemented on multiple clients. You can imagine that all of your clients will have this logic check. Even better is if we could move that logic behind one field in a schema. Now, with the new can add new bank account flag, you've only had to handle this logic once for all of your clients. We've found over time many instances like this where we can move more of the business logic behind the schema, reducing the amount of times you're implementing something and making it easier to dynamically change this. Imagine you've removed having a max limit to the number of bank accounts. If you are returning that as a value, there's no clean way to make that transition without force updating your mobile clients. But in this example, you can just set can add new bank account to always return true. There's a lot more we've been working on as we evolve our schema. You may have copied that you've thought of as client-side localized strings that actually rely on a business value to still convey true sentiment. By adding these business values that could change over time to our schema, we've gained more flexibility to update these business values over time without requiring a client update. Over time, we started to use GraphQL interfaces and enums more. Interfaces allow us to start ensuring that we only expose the right set of data at the right place. If we have a list view where the elements are all a different type, but have some common characteristics, we could still figure out the common parts and extract those to the interface, leaving our list view to be a list of the same elements, and only making type-specific calls at the detail level when tapping into the elements. We partner with the rest of the engineering team a lot to coordinate deprecations. And we've also been working on how we can, in general, just design our schemas to be product backwards compatible where possible. Our mobile clients may be older, but if they can seamlessly consume updates to our schema without needing to be force updated, then we've won. We've embraced the multiple client world by designing our GraphQL APIs to encapsulate business logic, be product backwards compatible, and we've partnered cross-functionally across engineering teams. So we have some answers to those questions that we've been asking ourselves. Apollo iOS lives in a data service layer, and feature frameworks interact with the data service through their view models and coordinators. We decouple as much of the app as possible from the shape of the schema to handle schema evolution gracefully. And we've embraced the multiple client life and designed the schema to encapsulate business logic and be product backwards compatible. This had us feeling like this. And let's be real, who else but Usain Bolt could express victory like this? Thank you for joining me on this journey as I share some lessons we've learned at Gusto with mobile and Apollo iOS. So thank you for joining today as we took a little bit of a journey through some of the lessons that we learned going from 0 to 1 with mobile and GraphQL. We have a couple of questions that have come in, and so I'll pick some of them. So we have a really interesting question from Kurt Kempel. Do you share queries across apps? If so, how? So for that, let's see, do we share queries across apps? We do not share the exact shape of the queries. We just, but often across, say, like our iOS and Android app, we do map and have like the same queries. We're just like, but we are redefining them in each code base. We sync up across the two teams pretty regularly just to make sure that we're querying for the same shape of the queries, and usually it should be pretty clear. based on the designs and what data you need, that we are sort of mapping that parallelly. Across mobile and web, sometimes the shapes of the queries are a little bit more different, but I think that just makes sense. Those clients are a little bit more different than our mobile apps. We have another, okay. So what was the frequency? This is a question from Gabby Zhu. What was the frequency of breaking changes, and how did you solve app versioning when the schema would break? Yeah, so we definitely had a little bit of a rude awakening the first time we experienced one of these breaking changes. And I think this is something that we're still going to be learning about over time. We have tried to reduce that, and we have solved this in a couple of ways. One is, I think, just like really strongly communicating what is going to end up being a breaking change. We are trying to work on having more tooling to catch those before them. And then we go through a deprecation process, basically. So if there is something that really does need to be a breaking change, we deprecate the field. That way, when the mobile clients pull the latest schema, they see that these fields are deprecated. We usually sync with the team or whoever it is that wants to deprecate that field to figure out like what their timeline is for when they want to move over to the old one. We switch to the new one. And then our plan here is that just depending on the nature of the breaking change, we will see like how much traffic we're comfortable with coming against the older version of the app. We did add an extra query. This query will return what the minimum supported version of the app is. And so when we are finally ready to be able to make that breaking change, what we'll do is bump that minimum version. And then once we've bumped the minimum version, then teams can safely remove the old parts of the schema. Let's see. Do we have, let's see. Wow, we have lots of questions. All right, lots of questions from Alan. Let's see. At what point did you start working with the backend team about the structure of the schema? Definitely from the beginning. So we actually started on our specific projects. The mobile team actually started building a lot of the schema first for part of the app. And then there were other parts of the team that was doing more backend things that took over some of that and were building out new features. But this is a pretty like regular thing. I think over time we realized more and more that the teams needed to be involved a little bit more as we designed the schemas, just because you think about different concerns on mobile versus web. And once both teams were there together, that's usually when we would surface the things where it's like, oh, this is like logic that we're repeating across multiple clients. Maybe this is something that we can move into the schema behind the schema instead of like repeating this across clients. So I would say pretty early on, a couple months in is really when we started to like notice this. Let's see. The hardest thing for you to wrap around with GraphQL, I think I know that early on, I think it was a little unclear to us like how to use fragments. At least for me, I know that was something that took me a little while to wrap my head around, and where are those fragments defined? Yeah, would be probably at least one of the things on top of my head. And let's see. When using Apollo iOS, you suffered from null checking everything. Yeah, or what's your strategy to determine nullability for object fields? Yeah, we definitely end up with a lot of null checks for places. It depends on the field. We do unwrap for some things if there's a good understanding of okay, I guess there's two types of null checks. One is if this field is null, is there a really good value for us to fall back to? In that case, it's usually when we define those in the extensions that I mentioned. But then there are others where like if this is null, then like something has actually gone wrong, right? Like the query has not gone through, and then we like pass that through our like error checking layer and maybe try and retry the query. Cool. And I think, do we have time for more? Okay, one more question. So this is a question from Mike Cohen. When you move the minimum schema version forward for your API, what is the experience for users of the affected mobile applications? So they will not be able to like get into the app. It's the very first query that we make. And we'll basically, we show an alert like on launch that says that you're not on the minimum version and you need to update from the App Store. And that's just, it's the only way to block querying an old version of the schema. All right. So I think that's all we have time for today. So yeah, thank you for watching I talk today and enjoy the rest of the conference.